Today we're going to talk about gradient. So the gradient is a measure of steepness or slope in a linear graph. It's the ratio of change in the y values, so how much the graph rises, how much the y values increase over time, over the change in x values, so over the run, over the increase in the x values. Or, just to write it as a simple equation, the gradient equals the rise divided by run. It shows the ratio of the rise to run. The gradient is often assigned this letter, the letter m. You might remember that we looked at m equaling the amount that y increases as x increases by 1. So if the x values increase by 1, that would mean that our gradient would just be equal to the rise, the amount that the y values increase. So that is what we were looking at before. So now we will be able to use this tool to work out what m is equal to, what the gradient, how steep or how quickly it's increasing or decreasing, by using this formula rather than having to look at x values just increasing by 1. So here we've got a few examples here. I've got a line here that's got a positive gradient. The y values are increasing as the x values increase as well. So the run that we have along here is 2 and the rise that we have is 4. If we moved along 2x units, we've increased by 4. So m, the gradient, is going to be equal to the rise over run, which is equal to 4 divided by 2, so the gradient is 2. Now with a higher m value, you get a higher steepness, a higher increase, a higher rate of increase. So if this was much steeper, in the 2 units that we would have moved along the run, the number here would be much higher, and that would make our gradient higher. So a higher gradient is a steeper graph. A lower gradient is a less steep graph. A 0 gradient, we're going to get it completely flat. So here we can have a look at what a negative gradient is going to look like. So a negative gradient, we see a decrease in y. The y values are decreasing, getting less and less as our x values along here increase. So here our run is 2 and our rise, it's not risen, it's decreased, so it's going to be -3. We've decreased it by 3. Decrease this by 3 along here. So the rise will be -3 and the run will be +2 because we've still increased the x values. But we are decreasing those y values. So our answer, or our gradient for this particular line here is going to be -3 over 2, okay, which is -3 halves, or -1.5. So that's going to be our gradient here. It's a negative gradient because it is reducing, it's sloping downward. So as I mentioned before, the gradient of a horizontal line is 0. That's because there is no increase in the y values and no decrease. There's no rise. So there cannot be a gradient. The gradient is going to be equal to 0. Similarly, or in a different fashion, the gradient of a vertical line is going to be undefined. We're not going to be able to calculate it because there is no run. There's 0 run along here. So having a look at, if we've got 2 points on a horizontal line that are separated by 2 units on the x-axis there is no rise up or down between our 2 points. So the rise is going to be 0. And that rise would be 0 whether there were 3 or 4 or 5 or 6 units. There wouldn't be any gradient, there wouldn't be any rise. So the gradient is 0, it is completely flat. So if you ever see m is equal to 0, that means you've got a flat graph, a horizontal line. So for our vertical line here, we've got a rise. We've got a rise of 2 units, okay, but there's 0 run. So if we were to substitute in a 0 run into our gradient formula, we're dividing by 0, which can't be done. So we've got that gradient of that graph is undefined. as we increase, go from 0, the gradient will increase and increase and increase further and further and further as it gets steeper. And as we approach, as we get closer and closer to our vertical line, the actual gradient will approach infinity. It will approach the largest number possible. Yeah. So just looking at a couple of examples, all we need to do with this is classify the lines A, B, C and D, whether their gradient, classify them with regard to their gradient. So having a look at whether their gradient is positive, negative, 0 or undefined. So having a look at A here, A is the Y values for A are decreasing as the X values increase. So because the Y values are decreasing as X increases, it's going to be a negative gradient. It's going to be a negative gradient there. Having a look at line B, so line B here is a vertical line. A vertical line is going to have an undefined gradient, The gradient for C, we've got the Y values of C are increasing as the X values increase. So because the rate of change, the rate of change of Y is positive, we're going to get a positive gradient there as well. So D, having a look at D here, D is a horizontal line, and because D is a horizontal line, the gradient is going to be 0. Our last example, we're asked to look at the gradients of these two lines here. So for our first line here, we've got 2 points. We can see it's crossing through the origin here at point 0, 0, and it's also crossing through the point 2, 3 here as well. So the rise is going to be an increase from 0 here to 3. So our increase is going to be 3, our rise is 3, and our run is how far along we've gone on the x-axis, how much the x-axis, x values have increased, and they've increased by 2. So our gradient is going to be 3 over 2, or 1.5. 3 divided by 2, or 1.5. Looking at our second graph here, we've got a point here of 0, 4, and a point here 4, 0. So we can see that it's going to be a negative gradient because the Y values are decreasing as the X values increase. So the rise is going to actually be a reduction, a negative value. Our rise in this case is going to be from 4 to 0 here. The Y value is going to go from 4 down to 0. So it's going to be a negative 4. So our rise is negative 4. We've decreased by 4 down the Y-axis as we've gone along the line. Looking at what the x-axis has done, it's gone from 0 to 4. So our run along the base here is going to be 4. So negative 4 divided by 4 is negative 1. And we can see that as our x values increase by 1, the y values decrease by 1. So we can see it goes from 4, y equals 4, x equals 0, if we add 1 to x, our x value there, we've gone down to 3. Then add 1 at 2, add 1, 1. So we are decreasing by 1 each time, and that's our gradient, negative 1.